All right, boys and girls, welcome back to the drive-thru. I'm here with my new fave student, Tara, and I'm going to try for the 5th time to successfully make this video, but I'm ready. The problem before is I was taking way too long doing it the hard way. Let me show you how to do this the easy way, and then we're going to apply vectors, and if you want to watch the end of the video, you can see how to do this with vectors. That's a better way to do it. So, like any other problem, this is going to start with a good widmapoi. So what we got is something that we're referring to as a slide. And this is an inclined plane. It's a very popular thing in physics. An inclined plane has an assumed right angle. That's going to be an important part of this problem. And we've got ice. The reason they're using ice is they're insinuating that there's no coefficient of friction, so there's no friction involved. Okay? This ice is being held in place by a rope. Maybe that rope is like going around a pulley and attached to like some anchor point, okay? And now we've got to talk physics real quick. So, 300 pounds. Pounds is a weight. A weight is actually a force, okay? So your weight is equal to your mass times acceleration. Our acceleration on Earth is 32 feet per second squared, or 9.8 meters per second squared. Okay? None of this is involving the problem, but I do want to explain it right. So, that is why you are weightless on the moon. On the moon, there is no acceleration. So you take your mass and you multiply it by 0, and you get 0 for your weight. Okay? All right. The reason I tell you that is that the tension is also a force, and they're asking us to find the tension on the rope. So all we have to do is figure out how much of the force is going in the direction of the rope. Now, you should understand that this block of ice wants to move that way, right? It wants to slide down the hill. All of the weight from the ice is going that way, because gravity moves completely vertical. So this is 300 pounds, and this is the key part of the problem. This is 22 degrees. So the easy way to do this, Tara, is just to think about how much of that 300 pounds is going in that direction, okay? And then the rest of that weight is pushing against the slide, pushing against the ramp. So you can imagine if this ramp was made out of paper, it would crash. But if the ramp was made out of wood, that wood would probably have enough strength to support whatever weight was on the ramp. Okay? So this blue vector is being split up into a brown vector and a green vector. And here is our right angle right there. So now we're going to use some geometry. That makes that a right angle. Do you agree, Tara? So now we can find out what this angle is. Let's see. 180 minus 90 is 90. 90 minus 22 is 68 degrees. But you can see that this is a right angle, and that's also a right angle. Oops. Due to the properties of parallel lines. So we also know then that this is 22 degrees, right? And what we really want to find is the tension and then the force that is perpendicular. So we literally can just use SOHCAHTOA to do this, Tara. So according to the 22 degrees, what is the brown side? Is it opposite, adjacent, or hypotenuse? It is opposite. What is the blue side? It's hypotenuse. So we're going to say opposite hypotenuse. That sine of 22 is the tension on the rope divided by 300. So the tension on the rope is 300 times the sine of 22. Okay, so 300 times the sine of 22. And you get 112.4. Okay? Pounds. So I want to make sure that answer makes sense to you. That is how much pressure, how many pounds of force is on the rope. So when you go buy a rope, it will tell you how many pounds it's like proven to be strong to. Okay? All right, now we need to find the green side. So, Tara, once again, according to the 22, is the green side adjacent, opposite, or hypotenuse? It's adjacent. The blue side is still hypotenuse, so that's going to be cosine of 22. We've got that called P for the perpendicular over 300. So P is equal to 300 times the cosine of 22. Make sure your calculator's in degrees, and you better be good at switching back and forth because it comes and goes. And you get 278.15. Okay? Now, I want you to know what you just found is the combination vectors for the 300. So, like, you could say that 0, negative 300 is equal to... I can't do that. It's too confusing for right now. That's the end of the problem for now. Now, what I want to do very quickly is show you how you could do this with a dot product. Okay? So you feel free to turn off the video if you want, but let's just do this relatively quickly. That's 22. Do you agree that would be negative 300? So now we can represent that blue thing as a vector. All right, let's see. Well, what is this? We can find it. Opposite, adjacent, that's tangent. So tangent of 22 equals 300 divided by x. Okay? So x is 300 divided by the tangent of 22. Can you do that in your calculator for me, Tara? $742.5. Okay, bear with me now. Now it dawned on me that what we want to do, let's call this blue vector U. And let's call this purple vector V, okay? If we go back to brown real quick, what we're looking for the tension of the rope is how much of this blue vector is being projected in the parallel direction of V. Does that make sense to you, Tara? So we're really looking for the projection of U onto V. So what is V? Oh, we have V now. V equals let's see, left negative 742.5, so left 742, and then down 300. So that's U, that's V. Do you remember the projection of U onto V, that formula? What is it? U dot V over magnitude of V squared times the vector value for V, right? All right, we can do this. So, U dot V, I'm going to do it over here. That would be 0 times whatever, which is 0, plus, can you do, well, we don't need that. Negative 300 times negative 300 is positive 9 with 4 zeros, right? Over, well, the magnitude of V is the square root of negative 742.5 squared plus negative 300 squared. It's just Pythagorean theorem, okay? But then we really don't even want V. We want V squared. So square both sides, and that cancels the square root. So if you could, Tara, could you just do 742.5 squared plus 300 squared? You can put in the negatives, but we don't need to. Very good, thank you. So 641,306. Whatever, 0.3. Okay? Now, and then we're going to take that and we're going to multiply it by the vector V. Okay? So, let's just get this number here as a decimal. Tara, will you do 90,000 divided by that 641,306 point? You get 0.14033. Times the vector V. Okay? We're almost to our answer here. So, our projection of U onto V, can you do, Tara, 0.14033 times negative 742.5? So it's going to be a negative. Negative 104.2. And can you do 0.14033 times negative 300? And you get a negative 42.1. So what I want you to understand is that brown vector represents this vector. Does that make sense? Now at this point there's no connection between this page. Remember, we said that the tension was 112.4 pounds. Well, this is the vector value for the tension. How can we find the actual tension? Do you know? We're just going to find the magnitude. I'm so pumped up about that. So, the tension will be the square root of negative 104.2 squared plus negative 42.1 squared. Are you putting that in your calculator for me? I'm so hoping this equals the thing we just figured out on the next page. All right, 112.4. Right? And look what we got over here. That's why that works. So now you know how to do it from a geometric standpoint. Find a similar triangle, break the weight up into its perpendicular parts. But at some point in physics, you're going to want to understand where the formulas come from, and they're coming from these dot products, okay? And I'm proud of that video. Boom!